We are going to find an equation of the plane that contains these three non-collinear points as you see here. So we shall take our approach as, let's construct a vector PQ and a vector PR, and if we take the cross product of these two vectors, then that will be perpendicular to the plane containing PQ and R. So when we construct the vectors PQ and PR, then we will just take component-wise difference, subtracting the values of the coordinates of the initial point from that of terminal point. So here you see -2 minus 1 would be -3, then 1 minus 2 would be -1, and so on and so forth. So what we did was that we constructed these two vectors and are going to take their cross product as we mentioned earlier. So let's go ahead and get the cross product here. So what you have is the cross product. The way we calculate is given by this, and if we go ahead and find the values, an easy way would be to go for the coefficients of I, j, and k. And if we want to do that, then for I, you just take the determinant of this portion. That is, you will just go ahead and this will be the coefficient of I. And then when you go for j, what do? You alternate the signs, right? So for j, the sign will be negative. So that's here. And then for the coefficient, what you would do is that you are going to ignore this column and contain these two here. So what we got here is, and I'm just going to type it in so we had to do this, we had to delete it, so I deleted it here. So that becomes the coefficient of j, and then we will write the coefficient of k as, and again alternating the signs, we will get positive sign, and the coefficient for k will be, let me show you that what we will do, we will go ahead and ignore these. So the coefficient of k would be how much? That will be simply this, okay? And then we are ready to, I will write them in or let me just keep them in the same form. So if we write them down, what we shall have is that here we get -1, then -9, and that's going to be how much? That will be -10, and here you will have -3 minus 12. So -3 minus 12 will be -15, and then -15 combined with this one is +15. Sorry, here I forgot to type k in, and for the coefficient of k we have +9, and then how much? -4. So that would be 9 minus 4 is 5. So what we got is that we got our vector as, I'm just going to write it in the regular form, -10, 15, and 5. So that's who the components are. So now we have this, that a plane that's perpendicular to this vector and contains what? These 3 points, and we can use any of them. So let's use 1, 2, 2. So, a plane containing this point and perpendicular to this plane, rather the plane will have an equation how much? Remember, we just did this in the previous video. We can go ahead and just take the dot product, and we will have, and we will have this, then y minus 2, okay, and then we will have +5, and then how much? Z minus 2 again, and that dot product will be 0. And if we go ahead and divide by say 5, which is a common factor here, or greatest common factor here, or we can divide by -5 if we would like. So just let's just go ahead and indicate this here, that we are going to divide by -5, and what that will do is that will give us 2 times, because that -10 divided by -5 would be +2, and here we will have +3 and -3 rather, and here we will get what? -1, and we are not even going to write that one. So that's what an equation becomes, and sometimes you are asked to write it in terms, or write in the form of z equals ax plus by plus c. So we can go ahead and simplify it. So here you go. So this is what this part simplified is. So we can set that equal to 0, and if you solve this for z, the equation will turn out to be what? Simply this, right? I hope I didn't go over that too fast for any of you. I'm afraid of going too slow. But anyways, now if you want, you can just graph the plane given by that equation and see it contains the 3 given points, okay?